my goal would be that we have some time to work on your homework today because it is the intro to a chapter. Six to 11. So, one thing that I will readily admit to you is there are certain things I teach now that I did not learn very well when I was in high school.
Oh no, why?
Because we were taught things differently. And it was like, memorize this process. You know, if you know how to do this, learn how to undo it by just reversing the process. These certain things that, like, I feel like I got cheated. And I will tell you, I'm very happy to now be teaching on this side of things where I feel like we've corrected how we teach you guys and expect you to learn and things like that. So when we talk about quadratic expressions or equations, it doesn't really matter if you call it an expression or an equation. Bless you. Just when we go to graph it, we make it an equation, so there's an input and an output, right? But, so let's, you know, the sum x squared plus 13x plus 40. Somebody said factor that. That's obviously a whole lot harder than, hey, what are the factors of 20? You're like, oh, 2 and 10 or 4 and 5 or 1 and 20. So factoring a trinomial. What did you say? What's a trinomial? What's tri mean? What's a binomial? If I tell you this is a binomial, x plus 8, versus that's a trinomial, can you tell me that? 3 parts, yeah, an expression with 3 parts. Now, more specifically, 3 non-like terms, right? Because we can't put any of those together. It's a trinomial. It's kind of stuck as a trinomial. Sophia, did you have something? Sorry, your hand went up, but I didn't. So, why, right? Why are we going to do this? Is, you know, the basis of what I want you guys to understand. Now, we'll get to the area model version of this. But why are we doing this? Remember, actually write down x squared plus 13x plus 40 if you would. And then write down equals x plus 8 times x plus 5. Now, one issue I run into is because I was about to do just that. Because I tutor people that are taking relatively the same math as you, and because I've taught this multiple years, I forget what I've taught you guys already sometimes. So, my bad.
You'll find out soon whether I like time.
Oh, right. I mean, that's my plan, right? So, if we've looked at Desmos a little bit this year, right? If I type in x squared plus, what do we have, 13x?
Yes.
Plus 40?
Yes.
Can anyone make an observation that relates that to the factored binomial form x plus 8, x plus 5? Well, yeah, because they said they equal each other, right? But what? So what's the point? Why use this?
Because it looks better.
Have we talked about what information this factored form will tell us? That's what I'm trying to ask first off.
It tells us a
Okay.
lot of things. I don't think you told us that is the. I don't think it's wait, this is called a parabola, right?
So if we look physically, tangibly at what we're doing, and this is the part that I never learned, right? True confessions, never learned this.
What, algebra tiles?
Yeah, seriously. So we look at real physical representations of what we have, right? We have x, y tiles, we have x tiles, x squared tiles, y tiles, the whole thing. Let's write an equation showing this area, but as a sum. So,
We could write it as an answer.
excuse me. So, xy is one type of tile that we have, right?
Yeah.
So we have an xy plus x squared. How many of those? Just one.
Plus 4y. Wait. Yeah, 4y. Yeah. plus 8. Plus 8. Oh my god. I can do the product. Great.
Now, if we do it as the product, how do we know what this is as a product?
You do the sides, so it's x.
Leanne, sorry.
So the vertical line is x plus 4. And then.
So you're saying this is x, this is 4. Okay, x plus 4.
And the other one is y plus x plus 2.
Ooh, y plus x plus 2.
Wow, look at that. So that's
Okay.
a binomial.
So we have a binomial times a trinomial here, which makes up here is a 1, 2, 3, 4, 5 quinomial.
Does that even exist?
No, we call it a polynomial. So thank you for asking that. Anything over trinomials, we pretty much just call poly. What's poly mean? Many. Yeah. Yeah.
So is it like you add the number of factors? I mean, the parts? You do the distributive thing.
So what we need to circle back to is if we want to go from here up to here, and we don't have the physical model, we are distributing. Now the danger here is there's a double distribution. X needs to go to the Y, X needs to go to the X, and X needs to go to the 2. But the 4 also needs to go to all of them. And then you put them all together, and that will get us back here. So, what is that area as a sum? It's written as a product, right? What is that area as a sum? No, you're writing this on your paper, because we need some stuff to reference back to. Now, this process can be nicknamed it can be nicknamed foil. Sorry, none of you understood why that was going to be funny because you don't know foil yet.
Is it 18x?
So it's 18x squared plus. It's
Hold
18x
on.
squared plus 9x minus 2 because that's.
Did I ask for the answer?
No, but I gave it to you anyways.
Do you know what foil is?
No.
I
appreciate it.
But then why are you steamrolling over me? I'm trying to talk to you guys about the way we double check this process, and you're just steamrolling over me. Foil is something that CPM doesn't even teach, but I want to make sure you know it's a strategy. Foil is the old way that we learned this, and it was like the only way. So props to Mr. McCulley, you did the best you could. I love you, man. He'll never see this video. But when I learned math in my high school math class, we learned how to foil, and that was it. And then when we went to factor, they just said, yeah, undo your foil. And we're like, what? And seriously, we didn't understand what we were doing. What we were doing is saying, if this is the area of the object, what could the dimensions be? Which now we have the dimensions, and we're trying to figure out the area. FOIL stands for first. What's 6x times 3x? 18x squared. Be careful that you have that squared. O stands for outer. What's 6x times 2? I stands for inner. -1 times 3x. And L would stand for first, outside, inside. We did the first, last. So please, on your paper, write out first, outside, inside, last.
First, outer, inner, last.
If you have binomials, right, 2 terms and 2 terms, thinking through FOIL is a way that we can double check that we get all of the multiplications that we need. Then there's no like word like FOIL, you just have to do the distribution and double check yourself. So you could make up a word like first, middle, last, outer, middle, like, I don't know.
Guys, let's figure it out.
So now, hey, no, we're not wasting time on that because I would like you guys to have time to work on your homework. And the more off task, off tangent you are, the less time you end up with for homework.
Yeah.
So now, put like terms together. 18x squared plus 9x minus 2.
Yes.
Now, here's the question.
Oh no.
If we wanted to graph this, and we didn't have Desmos or a graphing calculator, I gave you like a piece of graph paper or some axes. You could make a t-chart, right? And do like x, y, and plug in values and everything. But what if I told you we actually know 2 values without doing any work?
Oh, well, that's.
The y-intercept, which is -2, and then the x-intercept, which is 9. Yeah.
Yay.
I do know the x-intercepts though.
Okay, it's
It's 0 and 9.
it's 0. It's so it's -2 because it's just 0. 0, 0, 0.
Zero.
If x is 0, they all just cancel out, and then it's just -2, right?
Oh my god.
My zeros,
Zeros.
my x values,
Oh,
when
it'd be
y,
2 and
it's 2 because it's a parabola, right? It's a
So
parabola.
it'd be 2
You
and
know
negative
it's a
parabola
parabola
because of the exponent, right?
-2? What?
Wait, how do you know? Do you know it's a parabola because of the exponent?
Wait, how did you get negative?
Someone
Well, then you don't know instantly because you do math to get that -2/3.
Yeah. What's
It's
that?
something.
I love you guys, but one issue you have is when you're talking, you're not thinking. Zip it for a moment. Look at what we have up here. How in the world did I jump to these values being something we know? And remember, I'm not very good at math. I can teach it pretty well, but I'm not a computer. Like my brain is not like do math really fast sort of thing. I'm not like I didn't do anything special.
Did you divide them by
No way.
Sophia?
So, well, I noticed that is the, like what you're adding divided by what the x is being multiplied, but what you're adding is flipped around. So if it's positive, it would be negative. Negative, it would be positive. But I don't know why.
It's the 9 divided by 18. I don't know why the negative is there. Because 9 divided by 18 is 2/3.
Yes.
It's a parabola.
That's
One
that's
needs to
that's
be
one half.
negative,
I'm done.
one needs to be positive.
No, wait, you have to get that thing.
Can you explain?
It's divided by 6. No.
Just broke my smart board.
Oh no.
See, it's confused just like that.
I don't need this,
Well,
Oh my god.
and I don't need this.
yes, with that first one, so it's like the negative 2/3. There's a 2 and there's a 3, and you just kind of flip the
We are talking
Oh, I see it
about
here, I see
a
it here.
tangible physical object, right? We are talking about area,
Okay.
right? That's what we're talking about. The area of the object, the total space the thing takes up. That's what we're calling our y, or our f of x, if you would like. But when we have that equals, I could ask one of you guys. Yeah, what did we have? What was it in here?
6
x
minus
minus
1.
1, and then 3x plus 2.
Don't judge.
Is it -1 divided by 6?
Okay.
Y is the area.
It is.
So, yeah, because when we talk about what is this object, it's a thing, right? What we wrote down is the math behind the physical object we have, right? We're describing actual stuff. Now, the problem is we don't know what the x is, we don't know what the y is, but we're working with real space. This is what nobody ever explained to me. This is real. We're actually computing stuff. So imagine I'm buying a hot tub, right? And we're going to have this problem. And I'm deciding what size of hot tub to buy. Now, most hot tubs are square, so it's going to be an x by an x problem. Like either a 6-foot or an 8-foot or a 10-foot. And I just built a patio, right? Like, if you aren't aware, I literally just built a patio this summer. So let's say I want my hot tub on my patio to have 3 feet over here, 2 feet up here, 2 feet up here, and 15 feet right here.
So like the distance from the edge of the patio.
Yeah. And if I know what the area of my total patio is, let's say it's like, I don't know, 1,600 square feet or something like that. I'm just making all this stuff up. I can build, I can actually scoot my x over, right? I could put my x squared down here. I could move all these dimensions. So this 3 would join with the 15, the 2 would join with the 2. And what I really have is x plus 4 and x plus 18. Right? If I move some stuff around and just look at the area.
Yeah. Yeah.
What I could then solve is at what x value.
And that is the area of the patio.
Sorry, that's an 18. Will my area be most utilized? This will be the maximum hot tub I want to buy because I've just like made it all. I've done the math. What we're figuring out here is what are the x values given a certain y value, but if we don't have a y value we're shooting for, like the area of my patio, we can start by finding the zeros. And if two numbers multiply to make 0, then one of them must at least be 0. So if I
Anything times.
I was thinking of
set 6x minus 1 equal to 0,
Wait a second.
and I do the algebra, I get 6x is 1, and x is 1/6. If we set the other binomial, I guess I'll just move you all 3 separately, equal to 0,
Oh my gosh.
and do 3x plus 2. This now becomes 3x equals -2.
Wait, then why is it negative?
because subtraction from
Oh.
We're figuring out what value can be plugged in that will make that binomial 0. Now, x can't be both of these things at the same time, but if it's one of those things, it is 0. So what we first have found by factoring are the zeros. And then what gets really cool, and this goes back to the original x plus 8, x plus 5, look at the graph we have. Or look at the binomials we have. What values would make this 0? Well, what could I plug in here to make it 0? -8. What could I plug in here to make it 0? -5. What do I know about all parabolas?
They
cross the x-axis.
They go up and down.
They go up and down,
They cross
or
the
down
x-
and up.
They cross
You
the
know that.
x-axis.
That is something we know all problems.
Will the left side of the parabola look the same as the right side?
Yes.
Yes.
Why?
Because it says they're being
It's
parallel.
symmetric, right? Which means once we have these zeros, I also can find the vertex.
Oh my.
How?
Wait,
How did it get it?
Who can tell me, not everyone talking at the same time, how I can now find the location of the vertex? Liang?
Is it like the -8 minus the 5, the -5? So it'd be like negative. Wait, no.
Wait, -8.
Maybe 3. That makes 3 sense.
Your vertex will always, you might want to write this down, be directly in the middle of your 2 x-intercepts. So your zeros, your x-intercepts,
Wait, can you say that again?
the vertex will always be in the middle of your zeros, or the x-intercepts. They're the same, those words mean the same thing. The zeros are the x-intercepts.
How do you know what the y value would be?
Ah! So then, once we figure out the x value of the vertex, why won't you go away? Okay. Where in the world was that problem? This. So now we just said, well, okay, between -8 and -5, okay, there's a gap, and Liang, this is where I thought you were going. There's a gap of 3. Half of that is 1.5, right? I got to go half the gap. So we find out -6.5. But Sophia asked the very astute question that doesn't tell us our y value. Plug it in. So if we know the x of the vertex, plug it in, do the math, and you'll spit out the y. Now we have 3 points of the parabola, the 2 zeros from the factored form, and our vertex. And that essentially lets me know what the parabola is going to look like. It gets me a nice start. Yeah?
You just find the mean of the two numbers together.
That's where I was actually just about to go. The other way to do this is just average them, right? The mean of those values will be the middle because mean is the middle of 2 values. So if we look to factor these things, we actually, I don't know where they show it. We gotta look at the, so there's this nice trick that we use here. And not really trick. But on your paper, please write down 2x squared plus 7x plus 6. And I'm going to scroll so I have some space. Because now when we have multiple x squareds, like we have a coefficient, things get a bit tricky. What we know is we're working with tangible objects. So we're going to draw out, we want to figure out what rectangle dimensions have this factored form. And if I think back to my hot tub problem, I'm going to make my life easier and put my x squared down here, but now in this case we have 2x squared. And we know there's going to be some x value and some x value. Now one of these will have to be 2x, right? And I'll figure that out in a minute. But one of these is going to need to be a 2x to make 2x squared. Now the 6 will be from the constant value here and the constant value up here. So that 6 will go in the top right box. The 2 regions that are left make up my 7x together.
Wait,
It's like diamond problems.
wait, if this is x, then that has to be 7. And that has to be -1 then.
What do you mean it's like a diamond problem?
It's like you have to find the things that like make it.
Wait,
You have to find the two so that it works for both numbers. You have to find the thing. So you have to find so it'd be 3 and 2.
I agree, we're going to sum to 7x, right? So sums go on the bottom. But what would I put on the top?
The multiple.
The things that 6.
But if I have an x value here and an x value here, won't this end up being some kind of x squared?
6.
So the 2x squared?
Maybe 6x squared because they have to have 6.
If we go back up here, trust me, this will mean a lot more if I don't just give it to you, right? This is why we're like trying to figure it out together. One of these has to be 2. Let's just maybe, right? Let's just, that might be the 2.
So, but I think for the, when you're making like the diamond, I don't think you need to put the x there because you know that, like, you just know that the values are going to be.
Hang on to that thought for a second. If I throw the 2 there, and let's just hypothesize, let's put a 2 here. This would be 4x, right? And then to make a 6, this would have to be 3.
That makes 7 too.
And this is 3x. Ooh, ooh, ooh.
So that's correct.
Yeah, that's good. 2x plus 3 times x plus 3 y.
So we now know 3x and 4x.
Yeah. So that would make 12x squared.
But how does that relate back
Because
to
you
the
do 6
trinomial?
times 2. You do
6
the
times
cross multiply with the area model.
No, just that comes out.
I was gonna say just do
Yeah. Wait.
You do
2x times 6
Wait,
doesn't equal
oh.
12x.
So the form of parabolas we're going to get very comfortable using is y equals ax squared plus bx plus c. Please write that down.
Y equals ax squared.
The only number that is 2.
So
When we set up the diamond problem to figure out, now here's what's funny. You got to where we're trying to go because you're comfortable using the diamond, right? I would have never, in my high school self, have ever had any thought of how to do anything like this. This actually informs
is that what they kept
this.
on using
We spent all those reasons one idea.
So when we set up that diamond, the bottom is bx, right? It is that sum x value. And the top is c times ax squared. Sorry about that tiny little dot there. I don't know what it's doing. It is the constant times your ax squared. So that's how we got the 12x. And then these other two pieces are the other two parts of your rectangle. So actually, try that strategy with the B problem up here.
Wait.
I just see
What?
a bunch of letters.
Gosh.
Oh.
Hold on, let's wrap this all back together. So, we,
I don't know if I can
My
actually.
grade
don't worry, I'm over teaching. Don't worry, I'm over teaching.
Yeah, I really know this. So I'm like, okay, I might go back to math 1.
Yeah, honestly though.
Don't worry, it's all good.
Will you explain?
Scary.
I think I kind of got it, and then you just made
Letters
a
are
big old
fine.
knot.
Alright, hold on. We gotta wrap up A before we can move on.
Ah,
The other enemy is when you all talk at the same time out of panic. It doesn't help. That tells me the dimensions of my rectangle that I have below here are that. Right? Sorry to kind of be writing all over the place here. And that tells me my zeros, my x values when y equals 0, opposite of your constant divided by your coefficient.
wait.
So, -3 over 2. Or you could set it equal to 0 and do the algebra, but that's what you're going to get. Opposite of your constant divided by your coefficient. -2, divided by 1. No, it's just -2. Those are our x values. Those are the zeros. Now, you don't need to know the zeros yet. This part is unnecessary to you right now. Do not force your brain to understand that. What we need to be able to do is write out the factored form, the binomial forms of this. So if we try to do this again with B, write down 6x plus 7 plus 2, or 6x plus 7x plus 2, please. I'm going to clone this and then clear it.
Wait, 6x squared plus 7. Oh boy. I need connections right after math, and I don't mind.
So you can just like,
Yeah.
We need to play with SpongeBob and throw them around.
Yeah. I just. Oh.
So this is over teaching, right?
yeah, but this part, the way that we're going to walk through this is what you should be starting to understand.
Oh.
12x squared
Yeah.
will go on top here.
Yes.
And that's not actually something we're going to use. It's just kind of a placeholder for right now. 7x
Would go down.
goes on bottom.
It's very similar to.
And if we go to build the rectangle, or really we could just make it a whatever shape you want. This is 6x squared. This is 2. And 7x is split up between these boxes. We are trying to determine what goes in these boxes. That's why we're using the diamond. Yeah?
How do you know if you're supposed to multiply with the 2 or the 7x? Because you multiply the 6x squared by 2. So how do we know?
Do you multiply?
It's c times a, like, it's these work together. The sum part just goes to the bottom.
So how do we know which one's the sum and which one's the not sum?
So always your middle value, your just x value, is the thing that was added up from the outside and the inside. So this is also why I showed FOIL. Sorry, I am trying to piece this all together as I teach differently than I have before.
I feel like what you do is you over-teach and then you don't always piece stuff together, then I'm just very confused.
Just a bunch of random information about what that means.
Did I delete the FOIL page?
No. Mr. Hudson.
Oh. All right, so that FOIL page, and we'll circle this background to make you understand. The outer and the inner, if you have like the binomial set up the same way, the outer and the inner always come out to be x terms, just x terms, not x squared. So that's your sum, because you have to put the outer and the inner together when you distribute multiplication. So 12x squared, 7x. This is all I need to know right now. Are we comfortable getting to this step with the top being the c times your ax squared?
Wait, in the end, all of this is used just to try and figure out the y, right?
No. All of this is used for multiple reasons. We can find the y-intercept, the x-intercepts, the center point.
So we do this.
Once we know how to do this, we know how to do everything that we need to do.
So we learn how to do this so we can graph it.
Yes. Or vice versa, take a graph and figure out the algebraic.
Oh my god. You try to see the roll this in one head.
Okay, just absorb for a moment. Okay, quiet coyote. We put the product of our a and our c on top with that x squared. We put the bx on bottom because it's the sum. And now we have to figure out what values that can add to 7 will multiply to make 12. So 3 and 4, right? And of course they have to be x's because we're dealing with quadratics, not just the magic diamond like we used to. That tells me I come over here and I place a 3x and a 4x. Wait.
No.
No.
I had to wait.
Who said wait?
So, if you want to experiment with this, flip it and put the 3x here and the 4x there. It's going to change where your factored dimensions go, but it won't change your final answer. We know we're going to have an x value here and an x value here. We can either have 6 and 1 or 3 and 2. It has to be 3 and 2 because of what we have inside. I can't do 6 and 1 because 6 does not look like it will easily make a 4. And 1 does not probably easily make a 3. Yeah. But a 3 will easily make a 3, and a 2 will help us make a 4. So now that we know those, what does this have to be?
1.
1.
And the other one would have to be 2.
Does this get what we have in our rectangle?
Yes.
I think I
So
get it.
our factored dimensions are 3x plus 2, 2x plus 1. Now, I'm not even going to talk about zeros because that was way too much over teaching. I never realized.
You have time to do your homework.
No, you don't. So we come here.
You have time to do your
These are
homework, he
built.
says.
I want to get you guys comfortable with this. These are built set up like that,
Oh my.
right? So they've already filled in those b values. It's a diamond problem essentially. So guys, just start playing with what could work. If I have a 2x here and a 6x squared, this will probably be 2x because it'll help me make that 2x.
I have a feeling I'm going to be going to this note page a lot.
Hey, David, do you hear that you continually are saying things that aren't helpful to you, like making more sense out of this? You're just talking. So I appreciate that you're confused right now. I get it. Quadratics are confusing. What I don't appreciate is just talking to talk, right? If you're going to talk, ask a question, share something useful. Don't just talk to make noise. Please and thank you. Because unless you could solve all 3 of these, no offense, but you need to shut up and listen to me solve them for a moment.
I mean, I can't solve them.
Right. So you saying, I have a feeling, just listen, right? 2x is likely going to go there because we have the 2x up there. If it is, right, we're operating on a lot of ifs right now, then this would be 3x.
And then you'd have to do the 5 for the other one, so it would be 15x. And then the other one would be 1, because 1 times 2 is 10.
and we double check, does it work?
Yeah.
So our dimensions are 2x plus 5 and 3x plus 1. Here, well, this has a y, so this is going to need the y.
Yeah. And
This is going to need the x.
So then you
5
do-
and 15 going this way,
Yeah.
so,
probably going to have a 5
yeah,
here.
and then
That should be
you
a
have
3.
the 3 over there,
And
so
that's
you
a
can have the
negative
2
2.
above the 5. Negative 2. And yeah, that'd be 1. Ah!
Does it work out?
Yeah.
So now this is 5x minus 2, y plus 3.
I think
What do we
I
think is
might
going to go
do
here because there's a 12 and a 9 involved?
3.
3x.
And then
So then here would have to be,
And then above that, negative.
crap,
We
Here?
did- That should be a 4.
No. Yeah, 4.
4,
And then
that'd be
above that
negative
would be negative
3.
3. Ah! I think I kind of get this.
So now that you've come out of the moment of panic, here's why I overtaught like I did. The next 2 to 3 days are us doing those skills I just crash coursed you in. So instead of showing you today, here little kiddos, you can go to level 1, but you can't go any further. I essentially took you up to like level 4, level 5, but then we're like, crap, this is hard. And you only need to be at level 1, right? You only need to be able to do this right now.
Okay.
But if you move forward beyond today's homework, which I know sometimes you guys do, I wanted you to know where we're taking this. We're going to take this to starting with the trinomial, like Leanne figured out, we can use the diamond to generate what goes in the boxes. Then we just operate with that to figure out the dimensions. This was never ever taught to us back in the old day. So if you go and ask a parent for help with this skill, they're going to look at you like your hair's on fire. They will not know what you're doing because this is a new strategy.
I'm just like, I'm a little confused.
Now,
It's like one of the,
where does the diamond come from?
the cross multiplication.
The cross multiplication of
Wow.
the box.
Wow.
So we will talk about that more in the future.
Well, we do use that on the homework.
Have a wonderful day.
Oh.
Please come back from the cliff of I don't know how to do this.
I think you might have broke my mind and then somehow he's back there.
Super glue. Super glue.